This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we'll be continuing our lectures on velocity and acceleration and distance and time, basically generally on kinematics. So let's just review the things that we did. Okay. Yes. The things that we did earlier. First of all, we found out the difference between distance and displacement. Distance was basically a scalar quantity and displacement is a vector quantity. A scalar quantity is something where the magnitude is only of importance, and for a vector quantity, magnitude and direction both are of importance. So there's a very similar difference between speed and its counterpart in this respect, velocity. Here only the magnitude is of importance. Here the magnitude plus the distance is of importance. Now, right now we'll be doing some more conceptual part on the speed. We also learned that for velocity, which we'll be using very frequently and not speed, because in our case we'll be coming across the fact that we'll have to we'll need to present the direction and the magnitude. So we'll be using velocity more frequently than speed itself. So the formula for velocity was displacement over time. Now you can just switch the formula, getting displacement is equals to velocity times time, and time is equals to displacement divided by velocity. Now these are the three thumb rule formulas that you should always remember. But let me give you an example, a clear understanding. For example, this is my car. This is my car. Here I am. This is Adil. Here. And this is my starting position, which is point O. At time is equals to 0 seconds. The time here is 0 seconds. We haven't turned the stopwatch on. So I travel this distance to this distance, which is the position P, which is my final point, in 5 seconds with a velocity of 20 meters per second. Now this velocity that I'm stating right now, I'm saying that I am driving with a constant velocity. Mind my words, a constant velocity of 20 meters per second. That every second I had, this is our case number 1, that every second I had a velocity of 20 meters per second. Now let's find the distance moved. So very simple, all you do is just simply multiply velocity and time as we have seen with the formula, which is equals to the displacement. So this would give us 20 times the time taken to move, which is 5 seconds. This would tell me that I have moved 100 meters in these 5 seconds with this constant velocity of 20 meters per second. Okay, so now this is our case 1. But for example, we have a similar case where this is me again. This is me here. This is my original position. and this is my final position. And I am moving from here to here. At t is equals to 0, I start, and at t is equals to 5 seconds, I end it. At 0 is equals to, from 0 to p. Now this is me here, at t is equals to 5 seconds. But I increase my velocity. I am already at a velocity at this point. I'm not at stop here. Okay, I'm already moving here, and when I come here, I just switch on my stopwatch. So at this point, my velocity, I'm telling you all this, my velocity 1 was 10 meters per second. On this point, when I reach this point, my velocity is 20 meters per second. Now the question arises. The formula says velocity is equals to displacement over time, which means displacement is equals to velocity times time. So the question arises, which of the two velocities should I use, 10 or 20, to get the final? The question says, what is the final displacement? As in, how much displacement have I covered in this time? So we have the time, which is 5 seconds, but we do not exactly know which velocity to use. So always remember, this is very essential. Always remember that the v here is the average velocity. In this formula, always the v here is the average velocity. So first, in such cases where there is no, in the earlier case, we had just one constant velocity, one uniform velocity, 20 meters per second. So the average would be 20. So if it's the same, the average would still be 20. But in a case like this, where there are two velocities, which is one is 10 meters per second, the other is 20 meters per second, the average velocity would be found out by v1 plus v2 divided by 2, because they are two velocities. This would give me 10 plus 20 divided by 2, which is equals to 30 divided by 2, and 50 meters per second. Now I can use this formula. Velocity average is equals to distance over time, which gives me velocity average into time. So the time was 5 seconds and the velocity average was 15 meters per second. So if you use your calculator, the distance would be 75 meters. Always remember that we will, for this formula, we will always use velocity average, which means that we will take a velocity and assume that the car, for example, if this is the car, I'm really bad at drawing, this is moving at one particular velocity throughout, which is the velocity average. For example, if the velocity 1 is 20 meters per second, and by the time it reaches point P, the velocity is 30 meters per second. So if I have to find out the displacement or use any of these formulas, which is actually the same, what I'll have to do is I'll have to find the average of the two first. 20 plus 30. This will give me 50 divided by 2, which is 25 meters per second. Now I can use it as 25 times 5 if the time is given as 5 seconds here. This would give me 125 meters. So always remember that we are taking in consideration the velocity average. When you will be doing questions of higher levels, then you will know about how to do it accurately using the 20 meters per second and the 30 meters per second. But for now, at this level, this is the only formula that you will require in kinematics, to relate to speed, distance, and time. So you should remember this one, and always remember that this is the velocity average. So we'll be doing more questions on this, but for now, just remember this concept clearly. let me just review it once for you, that whenever the first case, a car is moving at a constant velocity, this is one of the cases that you will come across very frequently, almost all of the times. The car is moving at a constant velocity of say 10 meters per second, and it covers a distance of, let's just twist the question, it covers the distance of 100 meters. Find the time taken. Again, the same formula, time is equals to distance over velocity, displacement over velocity, sorry. This would be 100 times 10. Here we can directly use this velocity because this is the average. It's moving at 10 meters per second constantly. So we can use this formula directly. This would give me 10 seconds. However, for case number 2, if I have the same case, but the velocities are different. For example, this is point O, and this is point P, and I am moving at a velocity, initially at velocity V1 is equals to 22 meters per second, sorry, and velocity V2 is 26 meters per second when I reach. This means that I am already moving, and by the time the stopwatch starts, I am moving at a velocity of 22 meters per second. And when the stopwatch is ended, when the stopwatch is stopped, this is my velocity. Now, I will find the average velocity out of the two, because these are not the same and these are changing. So, to use this formula again, the distance is again 100 meters. Now to use this formula again, I will have to find out the average velocity, which would be 22 plus 26 divided by 2, which would give me, this is 48 divided by 2, which is 24 meters per second. Now my average velocity is 24 meters. Now if I need to find the time will be 100, again distance times velocity. The velocity average would be, always keep this in mind, that this is velocity average. And this would give me 100 divided by 24, which is equals to 4.17 seconds. So this is what we should always remember, that this is the velocity average. The one right here, so we are considering that the car is moving at 24 meters per second throughout the journey. Obviously, this makes our reading a little inaccurate, or probably proper inaccurate, but for this level, we will be forgetting about the inaccuracies and we'll be considering this velocity average. This velocity, the velocity at a specific point, like the velocity at O, which we know is 22 meters per second, and the velocity at P, which we know is 26 meters per second, this is called the instantaneous velocity, or the velocity at a particular point. This is what you see in your speedometers in the car. So these are the velocity, instantaneous velocities. From the instantaneous velocities, you find out the average velocity and then use it in your formulas. So I hope you remember this, guys, and we'll be making some more videos on the same chapter to clear your concepts. And if you have any queries, kindly just comment in the comment boxes below.